Every Frontier model ships with a model card. It tells you what the model can do, what it can't, and what it was trained on. Almost nobody reads it. I read them. Here's what you actually need. This takes 7 minutes. A model card is the spec sheet for a language model. Intended use, capabilities, limitations, training data and its cutoff date, evaluation results. The labs publish it on purpose. It is the closest thing you get to a manual. Here's why you need it. Almost every, "wait, the model can't do that," surprise in production was answered in the model card you didn't read. The context limit, the cutoff date, the languages it actually supports. It was all written down. You shipped first. The problem is the card is written by the people selling the model. The headline benchmark numbers are real and also carefully chosen. The card shows you the best case on tests the model is good at. What you're buying is how it does on your task. That's not in the card. Forget the marketing page. Here's what the card is really answering. The whole thing answers 3 questions. What is it good at? What is it bad at? And what does it know? Meaning what it was trained on and when that knowledge stops. Every section is just one of those 3. Intended use. This is what the lab built it for. Chat, coding, vision, whatever. Using it for something it wasn't designed for isn't forbidden. It's just on you when it underperforms. The card told you what it was for. The benchmarks. MMLU, the coding evals, the big percentage. These are real, on standardized tests. The catch is, your task is not the test. A high benchmark score is a strong hint, not a promise about your workload. Now the part that breaks brains. Context window, training cutoff, and knowledge are 3 different things, and people collapse them into one. The docs explain it technically. Let me try differently. Context window is how much it can read at once. Your prompt, the history, the documents you paste. Measured in tokens. It's the size of the desk. A bigger desk does not make the model smarter. It just fits more paper. Training cutoff is the date its knowledge stops. The model learned from data up to that date, and not one day after. Ask it about anything newer, and it will either admit it doesn't know, or, more often, confidently make something up. The cutoff is in the card. In bold, usually. So a huge context window does not mean the model remembers your last conversation. That's not in the window, unless you put it there. And a recent sounding answer about last week is not knowledge. It's past the cutoff. Big desk, old brain. Both true at once. The one mistake. The one in every launch thread, every "we switched models" blog post. Reading the headline benchmark and treating it as your success rate. 95% on their eval becomes, "it'll be right 95% of the time for me." It will not. You copy that number into your expectations. You ship. 6 months later, it's quietly worse at your 3 real tasks than the demo promised, because the benchmark was never your job. The card showed you their test. You needed yours. 3 rules. These cover 90% of what keeps you out of a postmortem. Rule 1. Read the limitations section first. The labs write down what the model is bad at. Reasoning gaps, hallucination tendencies, weak languages. They are telling you the truth about the failure modes. Believe them before production teaches you the same thing. Rule 2. Check the training cutoff before you trust any answer about recent events, new libraries, or current prices. It does not know anything after that date. If you need current facts, you give them to it. That's what retrieval is for. Don't ask the brain, hand it the document. Rule 3. Run your own eval on your own task. The card's numbers are the model's numbers, not yours. 20 real examples from your workload will tell you more than any benchmark on the page. We have a whole episode on that one coming. That's the model card. What it's good at, what it's bad at, what it knows, and when that stops. Read the limitations. Check the cutoff. Bring your own eval. Next time, how RAG actually fails. The confident answer pulled straight from the wrong document. Subscribe.